Okay, in this video I will finish my discussion on a review of fractions. We've discussed simplifying fractions, multiplying and dividing fractions. And I've also mentioned this is for a contemporary mathematics course. The idea being that I want you to understand how to work with fractions. It's not like we're not going to see these out in the real world. On the other hand, we don't want fractions to be an obstacle to you as you try to complete this course. And so you're going to have your calculator to do fraction work and as a backup, but it's always a good idea to have a good foundation in fractions. But anyway, so I call it a balanced approach. So let's go ahead and get started. Next here it says fractions that look different but are equal in value are called equivalent fractions. For example, some fractions that are equivalent to a half include 2/4, 5/10, and 40 over 80. Name 3 fractions that are equivalent to 3 halves. So I would encourage you to do that. All right, let's see how you did. So 6/4, 9/6, 12/8, 15/10, and I'll give you one more, 30 over 20. We could literally do this all day. So basically, if you have 3 halves and you wanted to change it to any other fraction, really all you'd have to do is multiply by like 2 over 2 or 3 over 3, 4 over 4, and you would get one of these other fractions. Now, when you multiply by a number like 4 over 4, you're just multiplying by 1, because any number over itself is 1. So for example, if you're wanting to change 3 halves to 12/8, all you're doing is multiplying by 4 over 4. So we sometimes call this building fractions. And when we do addition and subtraction, we need a common denominator, and so we end up doing this thing where we build fractions. So let's practice this. It says fill in the missing numbers for each of the following so that the answer is equivalent. So we have 3/4 times something gives you 9/12, or 9/12. You can see that 4 times 3 would be 12, or 3 times 3 would be 9. 3 over 3 is what we would use there. On letter B, we have 2/5, and we want to multiply by some fraction so that we get 15 in the denominator. Well, we need to multiply the denominator 5 by 3. So whatever we multiply the denominator by, we've got to do the same thing in the numerator. So we're multiplying 2/5 by 3/3, which again is just 1. I call it a magic 1. And when we do that, we end up getting 6 in the numerator. So 2/5 is equivalent to 6/15. We just have a different denominator now. On letter C, you have 5/8 is equal to some number over 48. Well, you can see that the 8 is multiplied by 6 to get 48. So we're going to have to multiply 5 by 6, and so we get 30 over 48. All right, so that's how we build fractions. Number 7, now we're going to talk about addition and subtraction of fractions when we have like denominators. So basically, you could see 1/5 plus 3/5 is 4/5. And so all we're doing is adding the numerators. Or if you had 5/9 minus 2/9, 5 minus 2 gives you 3, and the answer is 3/9, which reduces to a half. So a common mistake that students make is they add their denominators. So let me see if I can make some sense out of this. If you had 1, 2, 3, 4, 5, so 1/5, and you added that to 2/5. So I'm dealing with candy bars here. I'm a big fan of chocolate. So I have 1/5 of a candy bar, and I'm adding that to 2/5 of a candy bar. And so does it make sense that I would get 3/5 of a candy bar? I would have 3 pieces that are 1/5 of a candy bar. That's 3/5 of a candy bar. So you can see the denominator tells us the size of each piece, and the numerator tells us how many there are. And so the denominator does not change, but the numerator we're adding. So hopefully that helps you to make a little sense out of why we're doing what we're doing. So on letter A here, we have 7/8 plus 5/8, and that's going to be 12/8. And of course, we need to simplify. 12 and 8 are both divisible by 4, and you should get 3/2. On letter B, 7/24 minus 5/24, you should get 2/24, and that reduces to 1/12. All right, let's move on to the next slide. So here it says addition, subtraction of fractions with unlike denominators. So it says use these 3 steps. Number 1, find the least common multiple of the denominators. What we're finding is also called a least common denominator since we're working with fractions. But we're really just finding an LCM. Number 2, build each fraction as necessary so that its denominator is the LCM found in step 1. And finally, on number 3, add or subtract, or as done with problems 7a, b, and c above. I think there was just 2 that we did, so you can throw out the 7c. But that's where we added fractions that had a common denominator. So let me show you how this works. So first of all, we're looking for the LCD, or the LCM, of the denominators. And so in another video, I talked about how to find LCMs and GCFs. To find a least common multiple, we basically look at the multiples of 2 and the multiples of 8. So we have 2, 4, 6, and 8. Those are the multiples of 2. For 8, I'll do 8 and 16. But you can see that the first multiple of 8 is a multiple of 2. So 8 is our least common multiple, or it's going to be the LCD for this problem. And so I'm going to rewrite the fractions so that they both have 8 in the denominator. Well, one of them already has that, but let's go ahead and do the 1/2 first here. So I need the 2, which is in my denominator, to become an 8. So I'm going to have to multiply by 4. Well, that means I need to multiply the numerator by 4 in order to make it legal. This has to be equal to 1, otherwise it would change the value when I multiplied times 1/2. So by multiplying by 4 over 4, we're not changing the value of 1/2, we're just writing it in a different form. Let's see, so we would get 4/8, and we have 1/8, so we're going to add those together and we get 5/8. So I would encourage you to see if you can do the rest of these and then watch the video. All right, so on B we have 4/5 plus 8/15. So we need to find our LCD, and I'm going to show you a little trick here. We don't really need to write out the multiples of 5 and 15. Hopefully you can already see the LCD. What I do is I start with the biggest number and I look at its multiples until I find one that's divisible by the other number. Well, in this case, we're done because 15 is divisible by 5. And so our LCD is 15. So we're going to rewrite our fractions as necessary to get 15 in the denominator. Well, you can see, just like the last one we did, we need to change the first fraction. I need to multiply my denominator of 5 by 3, which means the 4 gets multiplied by 3. So the equivalent fraction to 4/5 with a denominator of 15 would be 12/15. And of course, 8/15 doesn't change. So when we add these, we get 20/15. And you can see 20 and 15 are both divisible by 5. And so we do get 4/3. And again, I would remind you, you should be able to put these into your calculator and get the same answer as well. But again, I'm preaching balance here. I think it's always a good thing to understand where your answers come from and what you're doing. I just hate for students to just blindly put things into a calculator and have no idea why the answer is what it is. So again, I'm preaching balance. All right, so on C here, I'm looking for an LCD. I have 2/3 minus 1/4. So I'll start with 4, the bigger number. And 4 is not divisible by 3, so let's look at the next multiple of 4. We just keep adding 4. 8's not divisible by 3, but if we add 4 again, we get 12. Notice 12 is divisible by 3, and so there's your LCD. So I need to rewrite each fraction with the denominator of 12. In this case, we'll have to change both. So to change a denominator of 3 to 12, I'm going to need to multiply by 4. So the numerator gets multiplied by 4, and we're going to get 8/12. And then my other denominator is 4, so notice 4 times 3 would be 12. And so I need to multiply the numerator by 3, and so we rewrite 1/4 as 3/12. So now we have 8 minus 3, which is 5, and we get 5/12. All right, last one. We have 7/8 plus 5/12. Let's see. We got to find our LCD, and the bigger number is 12. Notice 12 is not divisible by the other denominator, 8. So let's try the next multiple of 12, which would be 24. Well, 24 is divisible by 8, and so there's your LCD. So we're going to rewrite the fractions with a denominator of 24. So we're going to multiply the 8 there by 3. So the numerator also gets multiplied by 3. So we're going to get 21 over 24. Again, that's equivalent to 7/8. Just now we have the denominator we need. The 12 in the denominator we need to multiply by 2. And so the numerator gets multiplied by 2, and we get 10/24. So 21 and 10, we're going to get 31/24, and that one is simplified. All right, we do have one more thing to discuss here. So in numbers 9 and 10 here, we need to change from a fraction to a decimal. In number 10, we're going to go back the other direction, decimal to fraction. All right, so if you have 3/4, how do you change that to a decimal? If you know how to do it, I would encourage you to do it and then watch the video. Well, remember, a fraction can be thought of as a division problem. This is 3 divided by 4. I would just do that on the calculator. Now, it'd be nice if you could do that by hand, but most people would just do that on the calculator. When I was in calculus course, we wouldn't have done that by hand. We had plenty of other things to think about. So we're going to divide, and so you should get 0.75 or 75 hundredths. On letter B, 4 divided by 9, you should get a bunch of 4s. This actually keeps on going. And the way we write that is the number that repeats gets a bar over it, and so this is 0.4 with a bar over it. And then we have 5 divided by 11. You should get a bunch of repeating 4 5s. So the part that repeats gets the bar. That's 4 and 5. And so this is 0.45 with a bar over it. Okay, on number 10 it says write each decimal number as a simplified fraction. So the thing I always tell my students is if you can say a decimal, you can write it as a fraction. Decimals really are just special fractions. So let me tell you or show you what I mean by that. So 0.8 correctly said would be 8/10. And so we could write that as the fraction 8 over 10. And of course that reduces to 4/5. On letter B we have 0.56, which we would say as 56 hundredths. So that's 56 over 100. And you can see that we can divide by 2, but in fact you have to do that twice, or you can just divide by 4 and you get 14 over 25. And again, this is also something that can be done on the fraction that I show you in the video where I go over the basics on using the TI-30XS multi-view calculator. Okay, so last one here, this is 0.375, that's 375 thousandths. So that's 375 over 1,000, and that one reduces to 3/8. And that's one where I'd probably just throw it into the calculator. And if you put 375 over 1,000 into your calculator, it should reduce it to 3/8. All right, and that is it for this video.